So today we are going to do the next part of Newton's laws of motion. Last class we did till tension. So now we are going to do the first law of motion. So now we are going to do what? First law of motion. So first law of motion, if you will see in ninth and all we learned an object is at rest, wants to be at rest. An object is in motion, wants to be in motion until and unless an external force is not applied on the object. That is also correct, but now we are in 11. So we are not going to learn by that way. Here what we will say, that if net force is 0 on the object, then the object will not move. Let's see what is the meaning of that. Suppose this object is there and then we are applying a force. Like this object of mass m and 10 Newton of force we are applying in this 10 Newton. Then left force, right force is going to be 0. Upward force, downward force is going to be what? 0. So we can say left force is equal to right force. Upward force is equal to downward force. So whenever such type of cases comes where net force on the system is what? 0, then we can say the object will be in equilibrium. The object will be in equilibrium. So net force 0 means object will be in what? Equilibrium. Fine. So whenever the object is in equilibrium, we can say that is first law. Okay. So one point we can note from here in any numericals, it's an important point, that is in any numericals, if it comes net force is equal to 0, or they are saying like in the numerical, the system is in equilibrium. System is in equilibrium in the sense is what? It means upward force is equal to downward force, left force is equal to right force. So the object will be in equilibrium. So this point is too much important. In any numerical, if you will see the if equilibrium word comes, either it is in electrostatics, so magnetism, rotational motion, gravitation, anywhere, if equilibrium word comes, then one thing should in our mind, one thing should come. That is what? The system is in equilibrium means upward force, downward force is equal, left force is equal to what? Right force. So that we will do, we'll get answer. So we can say that if the vector sum in the system is 0, then we can say what? The object is in equilibrium. So net force is 0, and then the system will be in equilibrium. Fine, that is what is first law. Let's see now how numericals they will ask in this chapter. So one thing is for sure, that whenever the object will be in equilibrium. Okay, one more thing we are going to learn here in first law of motion is what is the difference between rest and equilibrium. So let's see rest and what? Equilibrium difference. So rest and equilibrium, if you will see, rest means force itself is 0, and here is what? Net force is equal to 0. Fine. It means what? Force on the system itself is 0, then the object will be at rest. Equilibrium means net force is equal to 0. Again, equilibrium means upward force, downward force is what? Equal. Fine. Let's see now. We'll see what? Few numericals. 5 kg and 3 kg it is given. They are asking find tension on both string A and B. Find tension on string A and B. If you want to find string like net tension on string A and B, See, any numericals, if such types of numerical comes and the system is an obviously in equilibrium, so any numericals comes, then we in mechanics the first thing we should do is what? Draw a free body diagram and then make equations. Let's see. We can say 3 kg, so 3g mg will be downward, upward will be, let's take there is tension. Here is also a point of contact, so here also be a tension, and then what? There will be mg downward, and there will be tension here t, so you will have to take here t1. Why? Because this will be different, because the string in between mass changes. So same string, same tension, different string, different tension. Different string in the sense is what? Mass is changed, or the material is changed, but here we are not considering the material of the string, because massless we are considering anyway. So let's see now, in 3 kg block how many forces are acting? 3g upward and then up, downward, and tension is here. In 5 kg if you will see, then 5g, and there is a tension here, and there is t1 here. So anyway t is equal to 3g and t1 is equal to 5g plus of t. So we can say t1, let's take g is equal to 10 meter per second square, acceleration due to gravity. So now we can say this is going to be 30 Newton, and this is t1 is going to be 30 plus of 50. So t1 is going to be 80 Newton. Fine. So by this way we can find tension. Let's see the next question. Next question, if you will see, the question which I am taking now is from NCERT only. This angle is theta. Let's take this mass as 5 kg. Let's take this angle theta is 37 degree, and they are asking find tension. Let's take this tension is T, and this is what? T1. They're asking if the system is in equilibrium. If the system is in equilibrium, then find T1 and T2. Let's see, to solve these types of numericals, you can also pause and then solve. So I'm solving directly. So what we can do here, we are again the same thing. In whole mechanics, we'll do the same thing. First, we'll write all the forces acting on the object. So the system is in equilibrium, right? So upward force, downward force equal, left force, right force equal, right? Okay. So now what we can do here is, this angle is what? Also 37 degree. This is 37, so this is also what? 37. We learned how to do component. So let's see if you guys forgot. Now we can do one thing here is, suppose this angle is theta. This angle is theta, and this is, let's take tension. So whenever theta is attached with any force, any axis which is attached with theta, that axis is going to be what? Cos theta. Apart from that is sin theta. So this is going to be what? T cos theta, and this is going to be what? T sin theta. What I told, if any axis is attached with theta, that axis is particularly what? T cos theta, and apart from that is what? T sin theta. Then of course we can say here will be two axes. One is here, and then one we can say here. So we can say this is going to be what? T cos 37, T sin 37. Now we can say downward is what? 5g. That's it. Now is there any other force? No, there is no other force. So now anyway we are supposed to equate, because the system is in equilibrium. So we can say T sin 37 is equal to T1. Now T cos 37 is equal to 5g. Cos 37 is what? 4 by 5. So we can say cos 37 is 4 by 5, sin 37 is 3 by 5. Fine. So anyway, if you let's cancel it. So tan 37 now. Tan 37 is equal to, why we will do like that? Okay, fine. Anyway, tan sine 37 is equal to t1 by 5g. Now cos 3 by 5 by what? 4 by 5. So ultimately we get cancel out. So 3 by 4. So 3 by 4 is equal to t1 by 50. So that's 150 by 4 is t1. So from that we can find t2 also. Yeah, so this is 2 and then this will be what? 75. So 75 means 36, 37.5. So T1 is how much? 37.5 Newton. And then you can put the values, we can get T2 also. So by this way we can solve. So again, whenever equilibrium comes, then directly we are supposed to equate the forces and then we can find anything, whatever we want to find, that variable we can find. Let's see one more numerical. If you'll see one more numerical, this angle is 37 degree and this angle is 53 degree. Then we can say T1 and what? T2, and this is 5. Now they are asking again if the system is in equilibrium. If the system is in equilibrium, find T1 and T2. Again, the same type of sums. Whenever equilibrium comes, you will get bored by the same type of numerical. Only one thing we should know, that if the system is in equilibrium, then upward force, downward force is what? Equal. And the second thing is what? You are supposed to draw all the forces. If any force which is acting at an angle of theta, 3 steps are there in first law. One is what? If the system is in equilibrium, then upward force is equal to what? Downward force. Second thing is what? How many forces are acting on the object. Third thing is what? We are supposed to, if any force is acting at an angle of theta, then we are supposed to do component of that. These 3 things if you will do, then any numericals we can solve. We'll see in the second law what is the crux of this. So crux to solve first law of motion is what? Whenever the object, any force is acting on the object, first draw all the forces on the object. If it is in equilibrium, then we are supposed to consider upward force is equal to what? Downward force. And the third thing is what? If this any vector quantity is acting at an angle of theta, then we are supposed to do component of that. That's it. Now we can say here that is 5G. Okay, the problem here is what? Tension is acting at an angle of theta. Whenever a tension is a force, if it is acting at an angle of theta, then we are supposed to do component of that. Simple. So we can say now anyway, this tension is again if any axis which is attached with theta, then we are supposed to do that will be cos theta. So we can say T1 cos 37 degree and this is going to be T1 sin 37 degree. Okay, now here we can say here what? T2 cos 53 degree and this is what? T2 sin 53 degree. These things we should do. Now cos 30 T1 sin T1 cos 37 is 4 by 5. Sin 37 T1 3 by 5 and then T2 cos 53 is what? 3 by 5. Sin 53 is T2 4 by 5. So these things are there. Let's see now. Let's equate that. So now we can say upward. In this object, if you will see 2 forces are acting upward. That is what? 3 by 5 T2 and one is what? T1 3 by 5 and then 4 by 5 and then downward is what? 5G. In this direction 4T1 by 5. In this direction T2 3 by 5. Let's equate that. Now we can say 3t2 by 5 is equal to 4t1 by 5. 5 cancel out. So 3t2 is equal to 4t1. One equation. Another equation, if you will see, upward downward. So upward two forces are acting. 4t2 by 5 plus 3t1 by 5 is equal to 5g. Okay. Now again, you can solve two equations, two variables. You'll solve it. You'll get answer. So let's see next question. Next question we can say here now like this. This is 3 kg, this is 5 kg, and this is angle theta. If the system is in equilibrium, again same thing. If the system is in equilibrium, I'm theta. Let's see if the system is in equilibrium, but then what? Find theta. So we can say downward is 5g, and then upward is tension, of course. Again, here due to this point you want to find tension, so tension will be in this direction. There is no change in string. There is no change in mass in between. Masses, string is massless as well as the pulley is also massless, so there will be no effect on that. Now we can see here. This is theta. This is 90. This will be 90 minus theta, and this is going to be what? mg cos theta. So this is theta here, right? So 3g cos theta, and this direction is going to be 3g sin theta. Now again, in this 5 kg block, if you will see, then how many forces are acting? 5g downward, upward is t. So t is equal to 50 directly, we can write. And in this block, if you will see, one force is t, and in this direction is what? 3g sin theta. So we can say t is equal to 30 sin theta. Okay. Now we can say t is equal to 50. 50 is equal to, from 1 and 2. From 1 and 2. So 30 sin theta. 5 by 3. So we can say sin 5 by 3 is how much? 37 degree. So sin theta, or we can leave like this, theta is equal to sin inverse 5 by 3. So theta is equal to 37. Okay. So by this way we can find the forces. This is all about the first law of motion. So first law of motion, only one thing we should know, and the numericals how they will ask, that is what they are going to ask. Anywhere, like if the object is at rest, it will be at rest until and unless an external force is not applied in that. Fine. That also we can say, and apart from that we can say net force on the system is 0. It means there will be no external, of course external forces will be there, but like the total force is going to be what? 0. It will be balanced, so we can say it will be in equilibrium. So whenever in any question it is written like equilibrium, then we are supposed to do only one thing, is what? Upward force is equal to downward force, left force is equal to right force. Any numerical comes in equilibrium type, then what we are supposed to do, if any force is acting at an angle of theta, then we are supposed to do component of that. Not any force, any vector quantity, either tension, either velocity, either acceleration. Any force is acting at an angle of theta, any vector quantity is acting at an angle of theta, we are supposed to do component of that. And then second thing, we are supposed to write in a particular object how many forces are acting, that we will do. they'll get answer from. Till here we'll see, then we'll see the next class.